NEC area classification ID1, according to the National Electrical Code, refers to Class 1, Division 1. This designates an area where flammable gases or vapors are, or may reasonably be expected to be, present in quantities sufficient to produce ignitable mixtures. These gases or vapors may be present continuously, intermittently, or periodically. The presence of the flammable gases or vapors is not necessarily a result of normal operations, but may occur as a result of leaks, ruptures, or failures in systems used to convey these substances. The area may be classified as ID1 if the ignitable mixtures are present only during normal operation or maintenance of equipment generated by the processing, use, or storage of flammable materials, or result from a probable malfunction of equipment. Examples of areas that may fall under the ID1 classification include refineries and petrochemical plants, specifically processing, storage, and handling areas, paint storage and mixing rooms, cleaning areas using flammable solvents, fuel dispensing facilities such as pump islands and storage tanks, and grain elevators during grain processing or handling. The electrical equipment in ID1 areas must be explosion-proof. This means it must be enclosed in a casing that prevents the release of flames or sparks and able to withstand internal explosions without damage or releasing sparks or flames. Firstly, understand the fundamental principles of area classification within the NEC. Secondly, recognize the specific criteria that define a Class 1, Division 1 location. Thirdly, identify potential sources of flammable gases and vapors in such environments. Fourthly, learn about the construction and operational characteristics of explosion-proof motors. Fifthly, familiarize yourself with the relevant NEC articles and standards governing electrical installations in hazardous locations. Sixthly, be able to apply this knowledge to real-world scenarios to ensure safe and compliant installation. To delve deeper into the subject of NEC area classification ID1 and explosion-proof motors, consider the following topics. Firstly, explore the different classes and divisions of hazardous locations as defined by the NEC, focusing on the distinctions between Class 1, Division 1 and other classifications. Secondly, examine the properties of flammable gases and vapors, including their ignition temperatures, flammability limits, and group classifications such as A, B, C, and D. Thirdly, investigate the design features of explosion-proof enclosures, including their ability to contain internal explosions and prevent the propagation of flames or sparks to the surrounding atmosphere. Fourthly, review the testing and certification procedures for explosion-proof equipment, emphasizing the role of organizations such as Underwriters Laboratories or UL and other nationally recognized testing laboratories. Fifthly, analyze the installation requirements for explosion-proof motors, including proper grounding, bonding, and sealing to maintain the integrity of the explosion-proof protection. Sixthly, discuss the importance of regular inspection and maintenance of explosion-proof equipment to ensure continued compliance with safety standards. Seventhly, explore the use of intrinsically safe circuits and equipment as an alternative to explosion-proof protection in certain hazardous locations. Eighthly, examine the application of area classification principles in specific industries such as petroleum refining, chemical processing, and grain handling. Ninthly, review case studies of accidents or incidents involving electrical equipment in hazardous locations and the lessons learned from these events. Tenthly, discuss the role of qualified personnel in training and ensuring the safe design, installation, and maintenance of electrical systems in hazardous locations. Electrical equipment intended for use in Class 1, Division 1 locations must meet stringent requirements to prevent ignition of flammable substances. These requirements are outlined in Article 500.5 of the NEC. Explosion-proof enclosures are designed to contain any internal explosion without allowing flames or hot gases to escape and ignite the surrounding atmosphere. The enclosure must be strong enough to withstand the pressure generated by an internal explosion and must have flame paths that cool the escaping gases below the ignition temperature of the surrounding flammable substance. Motors used in Class 1, Division 1 locations must be specifically designed and certified as explosion-proof. These motors typically have robust enclosures, sealed bearings, and other features to prevent the escape of sparks or hot surfaces. Wiring methods in Class 1, Division 1 locations must also be designed to prevent the ignition of flammable substances. This typically involves the use of rigid metal conduit with threaded connections and explosion-proof fittings to seal the conduit system. Sealing fittings are used to prevent the passage of gases, vapors, or dust from one area to another through the conduit system. These fittings are typically filled with a sealing compound that hardens to form a gas-tight barrier. Proper grounding and bonding are essential to minimize the risk of electrical shock and to prevent the buildup of static electricity, which can also be a source of ignition. All metal parts of the electrical system must be grounded to a common ground point. Regular inspection and maintenance of electrical equipment in Class 1, Division 1 locations are critical to ensure continued safety. Inspection should include checking for damage to enclosures, loose connections, and other signs of wear or deterioration. Any repairs or replacements must be made with approved explosion-proof components. The selection of appropriate electrical equipment for Class 1, Division 1 locations requires a thorough understanding of the specific hazards present. This includes identifying the type of flammable substance, its ignition temperature, and its flammability limits. It is also important to consider the potential for the accumulation of flammable substances and the ventilation conditions in the area. The NEC provides detailed guidance on the selection and installation of electrical equipment in hazardous locations. It is essential to consult the NEC and other applicable standards to ensure compliance with all safety requirements. Failure to properly classify an area or to select and install appropriate electrical equipment can result in serious accidents, including explosions and fires. In addition to explosion-proof equipment, other methods of protection, such as intrinsically safe circuits and equipment, may be used in certain Class 1, Division 1 locations. Intrinsically safe circuits are designed to limit the energy available to a level that is too low to ignite a flammable substance. Intrinsically safe equipment is typically used for instrumentation and control circuits. When working in Class 1, Division 1 locations, it is essential to follow all safety procedures and to wear appropriate personal protective equipment. This may include flame-resistant clothing, safety glasses, and respiratory protection. Only qualified personnel who have been properly trained should be allowed to work on electrical equipment in hazardous locations. The NEC is updated regularly to reflect changes in technology and industry practices. It is important to stay up to date on the latest requirements to ensure continued compliance with safety standards. Area classification is a critical aspect of electrical safety in hazardous locations. By properly classifying areas and selecting and installing appropriate electrical equipment, it is possible to minimize the risk of explosions and fires. Understanding the principles of area classification and explosion-proof protection is essential for anyone working with electrical equipment in hazardous locations. Proper design, installation, and maintenance of electrical systems in hazardous locations are critical to protecting people and property. The NEC provides a comprehensive set of requirements for electrical installations in hazardous locations. Consulting the NEC and other applicable standards is essential for ensuring compliance with safety requirements. In addition to the NEC, other organizations such as the International Electrotechnical Commission or IEC also develop standards for electrical equipment in hazardous locations. These standards may be used in countries outside the United States. It is important to be aware of the applicable standards in the jurisdiction where the equipment is being installed. The use of explosion-proof equipment is just one aspect of a comprehensive safety program for hazardous locations. Other important elements of the safety program include hazard assessment, training, and emergency response planning. A thorough hazard assessment should be conducted to identify all potential sources of flammable substances and to evaluate the risks associated with each source. Training should be provided to all personnel who work in hazardous locations to ensure that they understand the hazards and the safety procedures. An emergency response plan should be in place to address potential incidents, such as explosions or fires. Regular drills and exercises should be conducted to ensure that personnel are familiar with the emergency response plan. The goal of a comprehensive safety program is to prevent accidents and to protect people and property. Explosion-proof equipment is an important tool for achieving this goal. The selection and installation of explosion-proof equipment should be based on a thorough understanding of the hazards present and the applicable safety standards. With proper planning and execution, it is possible to safely operate electrical equipment in hazardous locations.